All right, so power is a concept right here you can see with this equation, but power is essentially the rate at which work is done. So you can think about if you were carrying a box of books up a staircase. And so you're going to climb this staircase here. So you're going to lift the box of books this distance, and you're going to apply a force, right? And so we know distance times force, or force times distance is work, right? But if you take the box of books and walk slowly up these stairs, and I take the box of books and I run as fast as I can up the stairs, I will be out of breath and you will be fine. So even though we did the same work, something is different. And what's different is the amount of time that it took us to move the books up the stairs. So time is very important when you're looking at work. Let's say I'm going to lift this box here. It's a 10 Newton box, and I'm going to lift it 1 meter over my head. Okay, so I go to lift this box, and it takes me 10 seconds to lift the box 1 meter. You could say that I did a work, I applied a force times a distance, so I did 10 newtons of work, and I did over 1 meter, I did 10 joules of work. But it took me 10 seconds to do that 10 joules of work. So if I divide my work by my time, I get a new unit, and this is called power. So my power would be only 1 watt. So the unit for power is a watt. It is the same as the football player. It's a watt. And yes, J.J. Watt does supply a lot of power as he does work moving through linemen in a very short amount of time. But it's not named after J.J. Watt, the unit of power. It's named after a dead engineer named James Watt. Okay, so the unit for power is watt, and it's spelled out W-A-T-T, and it's abbreviated with the letter W. And one joke I always have is this with kids. If a kid asks me, what's the unit of power? I reply, yes. Get it? What's the unit of power? Because you just said that the unit of power is a watt. Okay? Now let's look at the example where I move the box, the 10 Newton box 1 meter in 10 seconds. What if instead I could lift that box 1 meter in 1 second? Right now, I do 10 newtons of force over a 1 meter distance in 1 second. My power is 10 watts. And so I'm 10 times more powerful if I can lift that box in a tenth of the time. Which leads us to another way the equation for power can be written. Both of these equations should make it onto your equation sheet, but you can see here is an alternative form for power. So both of these should go on your equation sheet. Let's take a look at someone who understood how to use power in extraordinary ways. Someone who spent his entire life dedicated to the craft of Kung Fu, and one of my personal heroes, and this is Bruce Lee. Okay, so I'm about to hit play on this video. I think the volume should be matched up with what I have, but hopefully this doesn't hurt your ears. We'll talk about the physics of this punch in a second. So what's amazing about the 1-inch punch is I'm going to go back to where Bruce has it set up. And he's only got his fist, if you look at this, he's only got his fist an inch away from the board. And it said of the 1-inch punch that it could knock a 200-pound man on his back. And the key to this punch is that Bruce Lee is going to supply a force, right? He's going to supply a force through a small distance, D, and that distance is 1 inch. But the key to the punch isn't the force he supplies, it's the time he supplies it. Because his hand is in contact with the board for a very small time, right? We can think of the power as work divided by time. And if the denominator, the time, is very, very small, the power is going to be a very big number. You can think, if we can put numbers in, let's say that it's 10 newtons of work in 1 second. That's a power of 10 watts. But now let's make it 10 newtons of force in 0.1 second. All of a sudden now, this is 100 watts. So you see, as the denominator gets smaller, the power gets bigger. And so because he had trained his entire body to act as one lethal instrument, he could supply that force over that distance in a very short amount of time, which made the punch extremely powerful. It's said to be the most powerful punch ever known in humankind. Let's take a look at a practice problem here and see if we can get a grasp on how to work with power. We see here we have a 193 kilogram periodic table curtain. This is actually in one of our bathrooms. We have this as a shower curtain. So you can buy these if you're into science and you want to know the elements better. That totally get it, or get in. They have an equation, physics equation curtain you can get. It's all kinds of cool science stuff. But a 193 kilogram curtain needs to be raised 7.5 meters. So we know the distance the curtain needs to be raised is 7.5 meters. And it has to be raised in as close to 5 seconds as possible. So we have 3 motors to choose from. We have 1 kW, which is kilowatt. So this is 1,000 watts. We have this one, which is 3.5 kilowatts, so 3,500. And this one is 5,500. So what we need to do is find the power required to move this curtain 7.5 meters in 5 seconds. So let's do our table of knowns first. What are some things that we know? Well, we know the time is going to be 5 seconds, and we know the distance is going to be 7.5 meters. Now, we don't know the force, but we can calculate it because we know the curtain is 193 kilograms. So all I have to do is multiply 193 by 9.8, and I'll get the force. So I do that, and I get a force of 1,891 joules. So now I need to find the power, so I know which equation I'm going to use. I'm going to use this equation. The power is work divided by time. So my power is going to be my work, which is my force, 1891 joules, times my time, times my distance, which is 7.5 meters, and I'm going to divide that by the time, which is 5 seconds. And I solve this, and I get a wattage of around 2,800. After rounding, I rounded that a little bit, but 2,800 watts, which would tell me the best motor is the 3.5 kilowatt motor. In other words, you couldn't use this motor. It doesn't have enough power. It wouldn't be able to lift the curtain as fast as you want. And so when we talk about power, we talk about an ability to do work as quickly as possible. All right, so hopefully this power was another P word for you, productive. And I also hope that it was fun.